Hello, college algebra student. This video is for chapter 3.6, absolute value functions. We'll just study in details of absolute value functions, including how to write it, how to graph it, what is the x-intercept, y-intercept, what are some of the features of the absolute value function, and the application of absolute value function. So first of all, everybody knows absolute value function is written as f of x equal to absolute of x. This is the parent function, and this is how it look like. The most significant point in the whole graph is the corner point. We call it the corner point is at 0, 0. So if there is any transformation, you always watch where the corner points stay. And also you can see that there is some kind of direction, it's like facing up. Okay, and if you are to write it as a linear function, you can split it as a piecewise function because you can think of it as two lines. The first line is y equal to x when x is greater than 0. And this side is y equal to negative x when x is less than 0. So this is very often employed in calculus class. So what is how do I graph other absolute value functions? So remember the transformation. If there's a function that has f of x of negative of x minus 2, what kind of transformation is it, and how do I graph it and find the corner point, and also x-intercept, y-intercept? So first of all, let's say there is a negative outside, so that means there is a reflection over the up and down, right? Vertical over y-axis. Over x-axis is the vertical reflection up and down. And then there is a minus 2 inside, so it is a shift to the left or right, sideways, horizontal shift, but minus means you go to the right side, shift right by 2. So you can think of it as, usually we do the vertical first, you can do the horizontal first. So I would do right 2, so it should be like this, right? And then I do a reflection. Be like that. So this is our corner point. So you would say the corner point is you only move it to the right, so it's 2, 0. What about x-intercept and y-intercept? So we have to solve it. X-intercept is when set y equal to 0. So set the output side equal to 0, 0 equal to negative of x minus 2. So I'm going to solve it. So divided by 0 is divided by negative 1 to get rid of this. So it's still x minus 2. And then we're supposed to split it, but this is not a positive number. So we would just split it as x minus 2 equal to 0. If this is a 5 or a positive number, you would say x minus 2 equal to 5, x minus 2 equal to negative 5. So we only have one x-intercept, which is negative 2. So you would say x-intercept is, negative 2, it's 2, 0. Okay, what about y-intercept? Y-intercept is when you set x equal to 0. So if you set x equal to 0, that would be negative y equal to negative 0 minus 2. So that is negative 2. So y-intercept is 0, negative 2. The y is negative 2, so right here. So that's the features of the absolute value function. And then there is another one. I want to graph another one. So this is f of x is 2 to 2 absolute x plus 3 plus 1. So let's look at inside. Inside is horizontal. So luckily we only have one horizontal shift. It is a plus 3 to left by 3, right? And then we have vertical. I have a stretch vertically by 2. So it's like stretch up more and then up 1. So if you just sketching it, you can think of it as you move your graph to the left by 3 to negative 3, and then you up 1. So this is where the corner point is, and then basically you stretch it by 2. So you can quickly sketch it that way. And if you want to just do the points, you can do the table. But let's do the x-intercept. So when we do the x-intercept, we would set y equal to 0, right? So if I set y equal to 0 equal to 2 to the x plus 3 plus 1, what happened? I would have negative 1 equal to 2, x plus 3. I divide by 2, so it's negative 1/2 equal to x plus 3. So I isolate the x plus 3 absolute value, but it's negative number. So there's no solution because a absolute value should not never be that. And you can see that you can see that the graph would never have an x-intercept because it's the corner point is above the x-axis and it's facing up. So this is one of the case where there is no x-intercept. The other case would be if you have a graph like this. This is one case. Your corner point is above and then you're facing up, or your corner point is below and you're facing down. So these are the two cases where there is no x-intercept. How about y-intercept? Y-intercept is when we set x equal to 0. Set x equal to 0, that means y equal to 2 times 3 plus 1. It is a positive, so I don't need to do absolute value. It's equal to 7. So I do have the y-intercept is 0, 7. The corner is, you can see that the corner point is you do negative 3 and then you up 1 like that. And then y-intercept, no x-intercept, no x-intercept. Okay. Let's do the third example, which is application of absolute value function. So they say write an absolute value function to describe all number that are at a distance of 6 from the number 5. Absolute value function is used to describe distance. So if you want to find any number x at a distance of 6 from the number 5, means you minus 5, okay, from it, and it's equal to 6. So this is an equation. I don't think it is a function, but this describes numbers that are 6 distance from 5. So if you say from whatever number, that is equal to the distance. Use absolute value function to express the range of possible temperature of within 76 degrees plus and minus 2. So how can I express those? So within that means less than 76. So 76 is our middle number. I want it to be minus 2 and also add 2 on this side. So it's 78 to 74. So of course I can say 74 to 78, but I want to use the absolute value to say, I would say x minus 76. So this is the distance from 76 is less than or equal to 2. Within means it could be equal to 2 or less than or equal to 2. Same thing here, absolute value function to express the range of cost as within $100 plus and minus 5. I think $5, I suppose. So that means it is $100 and you want to find those that are minus 5 from it. Okay, actually it should be minus 5 and add 5 from it. So it would be it would be x minus 100 because the distance from this point is supposed to be less than or equal to 5. So that's all you need for chapter 3.6. It's just very straightforward. We use a lot of transformation and also the fact that absolute value function is used to model distance.